Hello students, this is Dr. Nitara, Geochemistry mentor, welcoming you for another session in electrochemistry. Today we are going to see about the construction and working of the nickel cadmium cell. Okay, actually this nickel cadmium cell comes under secondary batteries. So what are secondary batteries? The cells which can be recharged by passing a direct current through them are called secondary cells. Okay, so these are also called as storage cells or accumulators or repeated action cells. Okay, see this nickel cadmium storage cell or a nickel cadmium accumulator is also a rechargeable cell. Actually we have so many examples under the secondary cells, and they are nickel cadmium cell, lead acid storage cells, lithium batteries, etc., etc. Okay, see this nickel cadmium cell is otherwise called as the nickel cadmium storage cell or nickel cadmium accumulator. This is because they are rechargeable cells. Okay, see, although this nickel cadmium cell is more expensive when compared to this lead acid storage batteries, this is becoming more and more popular nowadays because it is smaller in size, lighter in weight, and has a longer life when compared to this lead acid storage cells. Okay, so today we are going to see about this important nickel cadmium battery and how it is constructed. Okay, actually it is a galvanic cell, otherwise called as electrochemical cell or voltaic cell. Okay, so why we are calling this as galvanic cell? Because here in the nickel cadmium battery we are converting the chemical energy into electrical energy. Okay, and it is made up of anodes and cathodes. See here, this anode is made up of cadmium. In nickel cadmium battery, the anode is made up of cadmium. Okay, it is made up of cadmium, and this cathode is made up of, cathode is a grid of nickel plated with nickel dioxide. Okay, so this is a nickel plate which is coated with nickel dioxide. Okay, so anode is made up of cadmium and this cathode is made up of nickel coated with nickel dioxide, right? So the electrolyte is an aqueous solution of potassium hydroxide. This anode and cathode, both anodes and cathodes are immersed inside the electrolyte, which is nothing but it is a 30% potassium hydroxide solution. Okay, this potassium hydroxide is mixed with water, and 30% potassium hydroxide solution acts as the electrolyte. Okay, see here, just like that of lead acid storage batteries, this anode and cathode plates are separated by means of separators made of insulating material. See here, anodes and cathodes are separated by means of an insulator, cadmium and this nickel coated nickel dioxide plate, and these two plates are separated by means of a insulator, that is a separator. Okay, next we are going to see the very important cell representation. See, always the anode will be placed on the left hand side. Okay, the negative electrode will be placed on the left hand side. So an anode is nothing but it is a cadmium, so CD hydroxide. Okay, cadmium hydroxide, CdOH twice, this acts as anode. So anodic compartment. Next comes electrolyte, potassium hydroxide. Next comes nickel. So cathode is nothing but nickel plate coated with nickel dioxide. So this is the main thing, nickel dioxide. So that's why it's written here. So this is the cell representation. Actually this is very, very important. Okay, anode, cathode and electrolyte is placed in between this anode and cathode. Okay, so you have seen the construction, how it is constructed. Okay, next we are moving into the working part. Actually this is able to produce 1.4 volt of electricity. Okay, this the cell has a potential of about 1.4 volts. Okay, next let us see how this nickel cadmium cell is working. Under working we are having two main reactions, one is discharging and another one is charging. Okay, so let us see what is happening during discharging. See, during discharging, when nickel cadmium battery operates, at the anode cadmium is oxidized to Cd2 plus ions and an insoluble cadmium hydroxide is formed on the anode. At cathode, nickel dioxide is reduced to Na2 plus ions and NaOH twice is formed. Okay, so in the first thing, that is during discharging, what is happening in the anode? See, this cadmium, it is getting converted to Cd2 plus ions first, and then it forms cadmium hydroxide. At the cathode, NaO2 is reduced to Na2 plus ions, and then we are getting NaOH twice. Okay, so now let us see one by one what's happening during the cell reaction. Okay, see, when the cell starts to work, first what happens during discharging is, first this potassium hydroxide, that is the electrolyte, it undergoes ionization and it forms K plus and OH minus. So here we are taking two molecules So 2K plus 2OH minus. Now let us see what's happening in anode. Okay, so as I told you earlier, in the anode, first cadmium gets oxidized to Cd2 plus, is it not? So in anode, what happens? Cd, it gets oxidized to form Cd2 plus 2 electrons. See here, since it is releasing 2 electrons, it gains 2 plus. Okay, now what happens to this Cd2 plus? It accepts the 2OH minus ions furnished by this potassium hydroxide. Okay, so 2OH minus, and it forms CdOH twice. Okay, now this is what, now let us write the overall reaction for anode. What are the things in common on both the sides? Cd2 plus in common, and the opposite side, is it not? So we are cancelling those two. So what else in common on both the sides in the opposite side? No, nothing. Okay, so let us sum up the overall reaction for anode. Cd plus 2OH minus gives CdOH twice plus 2 electrons, is it not? This is what happening in the anode. Let us see what is happening in the cathode. In cathode, see here, in cathode the NiO2 is reduced to Na2 plus, and finally it forms NiOH twice. Actually this reaction takes place in the presence of water molecule. Okay, so and this nickel dioxide, it accepts the 2 electrons released by this anode in the presence of water molecule, and it forms nickel hydroxide. Okay, that's what taking place in cathode. Okay, so let us write NiO2 plus 2 molecules of water. It accepts the 2 electrons released by this anode, and it forms nickel hydroxide, and also it releases 2 molecules of OH. Okay, now let us see the overall reaction taking place during discharging. Okay, so we are going to cancel the things in common. So what are the things in common? 2 electrons in common, 2OH minus in common. So let us cancel all those things. Okay, 2E minus, 2OH minus, 2OH minus. Now let us write the rest of the thing. Cd plus NiO2 plus 2 molecules of water gives NiOH twice plus CdOH twice. Okay, so this cadmium has been converted to cadmium hydroxide, and nickel dioxide has been converted to nickel hydroxide during discharging. Okay, this is what taking place during discharging. So that means both these electrodes, cadmium and nickel dioxide electrodes, are coated with cadmium hydroxide and nickel hydroxide. When this happens, the cell stops working. Okay, see, from the above reaction it is clear that there is no formation of any gaseous products. Rather, the products cadmium hydroxide and nickel hydroxide adhere to the surfaces of this electrodes, that is anode and cathode. This can be reconverted by recharging the cell. Okay, so now see, during this discharging, the cell can produce an EMF about 1.4 volt. During this discharging process, energy will be released. Okay, so now a discharged cell can be recharged by passing a direct current in the opposite direction, when the cell reaction gets reversed and the original substances get recovered at the electrodes. Okay, now let us see what happens during recharging. So recharging the battery, when nickel cadmium battery is recharged by passing electric current, the electrode reaction gets reversed. Okay, just the reverse reaction will be taking place. Okay, so what we have to do is we should directly reverse this anodic reaction and the cathodic reaction as such. Okay, so let us write the reverse reaction of anode first. Cadmium hydroxide plus 2 electrons. See, we are passing electric current in the opposite direction. Okay, so when you are passing electric current in the opposite direction, the reaction gets reversed. Okay, Now the next cathodic part, Ni, reverse this reaction, okay. OH twice plus 2OH minus gives NiO2 plus 2 molecules of water plus 2 electrons, okay. Now write the overall reaction. What are the things that will be getting cancelled? 2 electrons and 2 OH minus 2 OH minus. Write the overall reaction now. Cadmium hydroxide plus nickel hydroxide gives cadmium plus nickel dioxide plus 2 molecules of water. Okay. So when a discharge cell is recharged by passing a direct current, what is happening? The reaction is getting reversed and the original substance we are getting. If the original substances can be recovered at the electrode. Understood, students? And also the electrolyte concentration has been replenished. Okay, again it comes back to its original level, that is KOH is replenished. Okay. Now let us see the uses of this nickel cadmium battery. It is used to supply current mainly in calculators, electronic flashlights, transistors, and also in cordless appliances. Next we shall see some of the advantages. Okay. Actually it is very smaller and lighter. It has longer life than that of lead acid storage cell. It like a dry cell, it can be packed in a sealed container. So this nickel cadmium cell is having some advantages and usages. It is also having some disadvantages. Let us see what are those disadvantages. Okay. The main thing is it is more expensive when compared to lead acid storage cell. So that's the main disadvantage coming under nickel cadmium cell. Okay. Well, fine students, I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anita Raj, Geochemistry Mentor, signing off from you. Thanks for watching.